Students, in the last class we discussed about the isomerism in the coordination compounds. In today's class we are going to discuss about the valence bond theory (VBT) in coordination compounds. Okay, that is valence bond theory in coordination compound. This valence bond theory is explained by the scientist Pauling. Okay, you are all well known about this, the different theories and what is this valence bond theory explains about everything. Okay, but in coordination compound, how this valence bond theory is applied. Okay, so sometimes rules are there, students. First, the valence bond theory tells about the shapes of the compounds, like whether it is a octahedral, tetrahedral, whether it is trigonal planar, okay, whether it is an inner orbital complex or outer orbital complex. That's all tells about this. Sorry, that's all explained by using this valence bond theory, and also by using hybridization. So hybridization is Sp is there, Sp2 is there, okay. But here the coordination compound is done by d block elements, are exhibited by d block elements. That means there is a possibility of involvement of d orbital in the hybridization. That means there may be Sp, Sp2, Sp3, Sp3d2, Sp3d3, like that, including d orbital. They explain. Sorry, they show different hybridization. Okay, students. For different coordination number, different types of hybridizations. Understood? So in that, one thing I will explain. If Sp hybridization is there, then it is linear in structure. Okay. So Sp2 hybridized is there. This is coordination number 2. This is coordination number 3. So Sp2 hybridization means that is trigonal planar structure. Okay, so coordination number 2 means two types of hybridization possible, Sp3 and Sp2. If Sp3 hybridization is there, then it is tetrahedral structure. Okay, Sp2 hybridization means square planar structure. This is for what? Coordination number 4, Sp3 and Sp2. If coordination number 5 is there, then it may be Sp3d, okay, or Dsp3. So if it is Sp3d, then it is trigonal bipyramidal. Structure is trigonal bipyramidal. If it is Dsp2, then it is square pyramidal. And if the coordination number is 6, it forms either Sp3d2 or d2Sp3. Both the case, the structure is octahedral. Both the case, structure is octahedral. So if the coordination number 2 means that is AB2 type. So this one is AB3 type. It is not possible, then also I write. This one is AB4 type. Correct? This one is AB5 type, this one is AB6 type. This B represents what? Ligand. Understand? So linear, planar, tetrahedral, square planar, trigonal, bipyramidal, square planar, and octahedral. So in that, students, the very well-known coordination compounds is the coordination number 4 and coordination number 6. Okay, they are highly stable, and most of the complexes which formed until this era is most preferably coordination number 4 and coordination number 6 because they are comparatively high stable. Compared to all other coordination compounds, these two are high stable by their geometry. means they are the stable. So most of the coordination compounds are in the coordination number 4 or coordination number 6. So I write the specific structure, students. In AB2 type linear base, this is in this one. This one, structure 1. Okay, so structure 2, that is planar means like this. This is structure 2. Assume tetrahedral is structure 3, 4, 5, 6, 7. So structure 3 is tetrahedral. So listen, 1, 2, 3, 4. Okay, so this is D, B, B. This is tetrahedral. Similarly, with the coordination number 4, square planar is also there. Square planar means where it is A, B, B, this is in the form of square. This is structure 4. Okay. So next, structure 5 is what? Trigonal bipyramidal. So listen, this is A means this is B, B, B. Okay. This one is this is structure 5, trigonal bipyramidal. Okay. Next structure 6 is square pyramidal. So that is A, square, this one is pyramid. That is square pyramidal. Understand? Next, last one is students, that is octahedral. Here A is the structure. Here octahedral structure. So these are the we already told you that is coordination polyhedron. Okay, so coordination polyhedron means representation of the atoms which are bonded to the central atom in a three-dimensional space, that is called as coordination polyhedron. Okay, here in that, so for different coordination number, different structures are there. These are the standard structures of this compounds. Students here, listen. Here I said sp3, here I said dsp3. Here both are carbon coordination number with 4 only. But it forms sp3, shows sp3 hybridization. You can this will show dsp2 hybridization. Here there is no d orbital. Here d orbital is there. Similarly here sp3d and dsp3. So what is this? sp3 after d, suffix d represents and prefix d represents means, and rub this. Okay, so listen students, as I told you, so many number of ligands are there. So ligands like NH3, Cn, correct? Next, halogens are there, As I told you, those are called as what? Ligands. Different types of ligands are there, like water is also there, right? ENR is there, PH3 is also there, like this CN is there, Cl is there, correct? F is there, Br is there, NO2 is there, okay? Next CO is there, again NO is there. These are neutral ligands. So students, in this type, the main thing is nitrogen bonded ligands are there, carbon bonded ligands are, halogens are there. Okay? So one thing you have to remember, if the ligand is bonded to nitrogen, carbon are strong ligands, are strong field ligands. The ligands which are bonded from nitrogen and carbon, whether it may be NH3, Cn, COOH, sorry, not COH, Cn, CO, NO. Okay, so here bond is formed by nitrogen and carbon. If the ligands are bonded and the ligands consist of nitrogen and carbon atom as a donor atoms, then they are strong field ligands. Okay, next another one is halogens X. Next oxygen bonded, there is O2 minus and H2O, E, PBH3. Sorry, not this E. In this E, nitrogen is present, correct? E means NH2, CH2, CH2, NH2, correct? So nitrogen means there means that is also strong field ligand. So halogen, oxygen and other atoms. Okay, so those are weak field ligands. Strong field ligands and weak field ligands. So students, this strong field and weak field ligand sequence is explained by spectrochemical series. It's explained by spectrochemical series. What is this series says? So if the ligands consist of a nitrogen and a carbon atom, they are strong field ligands. If they are keep on moving, halogen, oxygen and oxygen bonded compounds means they are weak field ligands. Why they are called as strong field? Why they are called as weak field means? So listen. For example, if we take cobalt, okay? So not cobalt, iron maybe. Iron atomic number is 26. Its electronic configuration is argon 3d6 4s2. Okay, so Fe plus 2 you take means there is 24 electrons, that becomes argon 3d6, 2 electron left from here, plus 2 means 2 electron less. Okay, so 2 electrons are removed from this 4s option, it becomes 4s0. Students, here, if you write the box diagram, here 1, 2, 3, 4, 5, 6 electron will present. Correct? So here, why these are called as strong field, why these are called as weak field means, assume this is 3D orbital. After 3D, 4s is there. Next, 4p is there. 4s, 4p. Correct? So here in this, what happens? This one is 4s, next one is 4p. So here students, if nitrogen bonded atoms are there, then what happens? These electrons itself pair up. Okay, they have the capacity to cause the pairing up of the electrons within the d orbital. That's why they are called as strong field. If strong field ligands like nitrogen and carbon is present, then the pairing up of electrons takes place. Okay, next. It is like this. Okay, if any ligand is bonded to halogen or oxygen or a water molecule, then they are weak field ligand. So then pairing up doesn't take place. The next empty orbital is considered as a vacant orbital. Understand? So if the ligands causes the pairing of an electron, then they are called as strong field ligand. If the ligands doesn't causes the pairing of electrons, then they are called as weak field ligands. That strong field and weak field explained by this spectrochemical series. So the simple thing you have to remember is, if any ligand is bonded to carbon and nitrogen, they are very strong ligands. Except in carbon and nitrogen, if any other atoms are bonded to the ligands, they act as a weak field ligands. Understand? So the next one, students. So this is all about the concept we are going to know about before writing the structure of the compound. So I will explain one structure, then you will understand what is the use of this spectrochemical series and what is the use of this pairing of an electron, why we need it. Okay. So the structure I am going to explain here is very important for 3 marks. Explain the hybridization of the molecule, then we give that is CO NH3 6 times 3 plus. Explain the structure of the molecule CONH3 6 3 plus. So using valence bond theory. This is the question they are going to ask. I'll discuss the hybridization of the CONH3 6 3 plus molecule. Okay. So if this question asks, that carries 3 marks. So students, in the coordination compound, as I told you, you get 3 marks, 2 questions. Okay, so in that, one question is compulsory from this 4 structures. So there are 4 compounds are there: CO, Cl6 3 minus, NiCl4 2 minus, and NiCl4 2 minus. Among these 4 compounds, any one is compulsory, 100% question for examination for 3 marks. Among these 4, any one is 100% question. Understood? Are you getting my words? So, CONH3 6 3. So, we will discuss one by one. So, first, consider CO is equal to atomic number is 27. Then it's electronic configuration. Argon 3 8 7 4 is 2. Atomic number of cobalt is 27. Its electronic configuration is argon 3d7 4s2. Okay. Next. So listen, here it is in +3 oxidation state, correct? Understood? So CO +3 means 3 electron less. Understood? So 3 electron less. So then it becomes argon 3d 4s. Here 2 electron less means 0. So 3 electron we have to remove. 1 from d orbital means 3d6. So cobalt +3 oxidation state is there. So cobalt +3 ion configuration is argon 3d6 4sc. Okay. Next slide. The box diagram. Box diagram for CO +3 ion. Here it is. Listen. 1, 2, 3, 4, 5. This is what 3D orbital. After 3D, 4s. Next, 4p. Next, 4d. You have to write all this. Okay. So first, how many electrons are here? 6. In 3D 6 configuration means with the cobalt plus 3 ion we are writing 6 electrons are there. So 1, 2, 3, 4, 5, 6. So next you have to check students which ligand is attached to this and bonded to this cobalt atom. Which is the ligand here? NH3. NH3 is a strong field ligand or weak field ligand? Strong field ligand. If strong field ligand is there, then whether the pairing takes place is not, pairing up takes place. Okay. So here NH3 is there. That means so NH3 is a strong field ligand. So pairing up takes place. Right? So next, we will again write the box diagram here. Here 3D. This is 4s. This is 4p, and this one is 4d. Okay, pairing up takes place means here already it is paired. Again 1, so this electron pair up here. Again 1, so this electron pair up here. So 6 electrons are there, 6 electron gets paired up. So students, after pairing up takes place based on the ligand, you have to check how many number of bonds are bonded to this cobalt atom. Here you have to check the secondary linkage. Right? Here the secondary linkage is how much? 6. Means the cobalt should possess 6 bonds. Okay? Including this empty orbital. You have to choose empty orbital here. If at least one electron is present here, we cannot choose it as an orbital pair. Understood? In coordination compound, we want complete empty orbital. If any one electron present, it is not possible to select that orbital. Understand? So here, empty orbitals, how many we want? 6. So this is 1, 2, 3, 4, 5, 6. Right? So if we select this, then we will get how many d orbitals? 2. D2, 1 s orbital, 1, 2, 3 p orbital. That is D2 sp3 hybridization. So after you write the hybrid orbitals of CO plus 2 ion is, this is hybrid orbitals of Cu plus 3 ion. So here you just separate this pair of electrons here like this. Okay. Next you consider the 6 hybrid orbitals. 1, 2, 3, 4, 5, 6. So these 6 are D2 sp3 hybrid orbitals. So in that students, next you have to write CO NH3 6 times 3 plus means. So this is the box diagram for the paired electrons. This is the hybrid orbitals with the electrons from the nitrogen atom. These are the electrons from the nitrogen atom. From nitrogen atom, which electron? NH3 means it is in this form, correct? These electrons come out with these empty orbitals. So such type of ligands are 6 times here. So 6 lone pair of electron from each NH3 group going to occupy the vacant d orbitals. Okay. So this is D2sp3 hybrid orbitals means what is the structure here? Octahedral. Correct. So here the central metal atom is cobalt. Correct. So here 1, 2, 3, 4, 5, 6 bonds. Here all are bonded through a hydrogen atom, that is NH3. This is the coordinate one. And below the complex we have, correct? So overall complex is written by 3 plus charge. The structure is written as completely, this form means the entire structure is written like this. Instead of that, I will only this much, 3 plus charge. Okay, so this carries 3 marks. Okay, you have to write the electronic configuration, you have to write the configuration of the atom, next you have to write the configuration of the ion, next box diagram of the ion, then whether the ligand is a strong fit or a weak fit. Comparing with that, you have to check the hybrid orbitals. After writing the hybrid orbitals, you have to write this thing, and finally the structure. Next, the 4 things you have to mention here. That is very important. This is sp D2sp3 hybridization. First thing is this complex is D2sp3 hybridization. Next is octahedral complex. Octahedral complex. So consider here. Whether it is diamagnetic or paramagnetic, that depends upon the unpaired electron. Here, all are paired electrons. If all are paired electrons, means it is diamagnetic. Correct? Here in the hybridization, so listen, 4s means this is the inner orbital, correct? 3d, next 4s, 4p, 4d. This is outer d orbital. This is inner d orbital. So the hybridization is, and this complex is inner orbital complex. Okay, students, if they are diamagnetic, then they must have low spin. So these points are very important to write after writing the hybridization of the compounds. One is hybridization, second one is structure, third one is magnetic property, fourth one is whether it is an inner orbital complex or an outer orbital complex, and last one is whether it is a low spin or high spin. So listen, if it is diamagnetic, then it is low spin. If it is paramagnetic, then it is high spin. Or even check, if it is a inner orbital complex, then it is low spin. If it is outer orbital complex, then it is high spin. Understand? So this is all about the hybridization of CONH36 3 plus 1 cube. Understood? So if you write this thing without missing any one step, means you will get complete marks. Step by step you have to write. Why I am telling you again and again is, so there may be a chance of getting only this product, so this compound as a question. As I told you, among 4 compounds, one is compulsory. This may be the question. Okay? Understood? is COCl6 3 minus. COCl6 remains. Next. So first, what you have to do, write in the configuration atomic number of this central metal atom as it is a cobalt. Its atomic number is 27. Okay. Next thing is writing the electronic configuration of atom. Argon 3d7 4s2. Next here it is in plus 3 oxidation state. How? So cobalt is X, we don't know. This is 6 into minus 1 because Cl is minus 1, that is equal to minus 3. Okay? X minus 6 is equal to minus 3. X is equal to minus 3 plus 6. So X is equal to plus 3. So this is already I explained in the nomenclature how to calculate the oxidation state. So here, so cobalt is in plus 3 oxidation state means number of electron is 24. Correct? So then the electronic configuration is argon 3d6 4s0. Okay. So next thing is writing box diagram for CO plus 3 ion. Okay, students. Here this is 3d orbital, 4s orbital, OP orbital, and 4d orbital. Okay, here 6 electrons are there in d orbital means 1, 2, 3, 4, 5, 6. That is 3d6 configuration. So students, the very important thing you have to remember here is this whether they take space or not is depends upon what? The ligands bonded with the central metal atom. Here ligand is chloride, that means halogen. So halogen belongs to weak field. So it is a weak field ligand means, so you write here Cl minus is a weak field ligand. So pairing up cannot take place. Okay, so if pairing up cannot take place, then the hybridization follows the same way. 1, 2, 3, 5. So this is 4s, this is 4p, and this one is 4d. This is 3d, 4s, 4p, 4d. So pairing up doesn't take place, means students, this remains as it is. Correct? So what I said? We need a empty orbitals. If even at least a single electron present, then it is not taken as a sorry, it is not involved in the hybridization. So we want completely empty orbitals. So from here we will start. So how many empty orbitals we require? We want 6 consonants, 6 empty orbitals. So it is 1, 2, 3, 4, 5, 6. So consider this 6 orbitals. Okay, students. So how many s orbital is there? 1. 3 orbital is p. P orbital is 2. So that is sp3 due to hybridization. So next, the hybrid orbitals of CO3 plus. So you write it separately. This is paired electron, that is 3d orbital. This one is 6 sp3 due to hybrid orbitals. Okay, so in this hybrid orbitals, the electrons from Cl gets piled. Okay, so this shows the complex one. And you write CO, Cl6, 3 minus. The hybrid orbitals are CO, Cl6, 3 minus. Okay, so here I use colored pen. So you just represent the electrons in the dotted structure while you are writing in the examination. It is hybrid orbitals. Understand? Don't use colored pens in the exam also. Next, once we got that it is sp3 d2 hybrid orbital. So then the structure follows octahedral structure. So central metal atom is cobalt. Here bonds. Okay, here it is Cl, 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 Cl and Cl. All are coordinate bond only. Okay, so both sp3 d2 and d2 sp3 follows the octahedral complex. So here, all to the power of this complex, what is the charge? 3 minus. Here the charge is 3 minus. Understand? Now you have to write here the conditions of these complexes. Okay? Here, which type of complex it is? First, the hybridization is sp3d2 hybridization. Correct? Second one is structure. The structure is octahedral. Okay. Next, whether it is a paramagnetic or diamagnetic, listen here. Singly filled electrons are there. Singly filled electrons are there means that is paramagnetic. If it is a paramagnetic, then it has high spin. Spin is very high because this is plus of minus of plus of plus of plus of plus of. Correct? They are high spin complex. Next, the last one is they are outer orbital complexes. Why they are outer orbital complexes? Because the hybridization involves the 4d orbitals, not 3d orbital. Here 4d orbital means it is an outer d orbital instead of outer orbital complexes. Understand, student? So this is all about the valence bond area of the coordination compound COCl6 3 minus. So this is also carries 3 marks. In both the cases, the thing is in one compound the pairing up takes place, in other compound pairing up doesn't take place. If NH3 or Cn, not only NH3, if NH3 or instead of NH3 they give Cn also, then also pairing up takes place. Remember one thing, if carbon bonded and nitrogen bonded compounds are there, then the pairing up takes place. So all the hybridization until you will do easily, students. The next thing here is the very important thing you have to remember. So this will decide which is the structure, which is the hybridization of your complexes. Here it is before compound I taken, It is as a strong field ligand because NH3 is the ligand there. Okay. Here Cl, since it is a weak field ligand, pairing of doesn't take place. Okay. So this is the thing. First thing, you have to take the atomic. So you have to write the atomic number. Consider the electronic configuration of the atom. Then oxidation, calculate the oxidation state in the complex and write the ionic configuration here. Okay. Once you write the ionic configuration, write the box diagram for ion. Once you write the box diagram for ion, consider whether which type of ligand is bonded to the central metal atom. So based on that, check whether it is a pair of takes place or not. When if pair of takes place, then count the number of vacant d orbitals. The number of vacant d orbitals depends upon what? The secondary valency. If your bond is 6, we want 6 empty orbital. If bond is 2, we want 2 empty orbitals. If bond is 4, we want 4 empty orbitals. So here it is 4s, 4p, 4d is there. So here it is a hybrid orbital is here. So this is the structure. So here 4d orbital involved means that is a outer orbital complex. Singlet filled electrons are there. That's why it is paramagnetic and also it is high speed. Its structure is sp3d2 and this one is octahedral. Okay. So these two is very important, students. In today's class, you practice this. In tomorrow's class, I'll explain the structure of right here NiCN4 2 minus and NiCl4 2 minus. So students, consider this one as HW for you people. Okay, you do it and upload it in the group. Okay, so same thing you follow. Here the atomic number of nickel is 28. Cn is a strong ligand, Cl is a weak ligand. Here pair up takes place, here pair up doesn't take place. And I guess certain structures with respect to the hybridization, you just do it and you upload it in the group. Okay. So reminding about these two structures, I will explain in the next class. Thank you.